The world is changing at an astonishing pace. Soon, most vehicles will be electric. The green revolution requires the ever-increasing production of lithium-based batteries. For this to happen, global lithium production needs to be more than tripled by 2030. This can only be achieved by using new sources of this metal. The Dead Sea is one of the natural wonders of the world. It is one of the saltiest bodies of water on Earth. Due to its abnormally high mineralization, the Dead Sea is exceptionally rich in minerals, compounds of magnesium, bromine, potassium, calcium, which have been mined here for decades. Lithium resources in the sea are estimated to be more than 2 million tons, which is equivalent to 12 million tons of lithium carbonate, a compound needed to make batteries. This makes it possible to produce up to 100,000 tons of lithium carbonate annually, with a potential annual income of more than $1 billion. Traditionally, lithium has been mined using natural evaporation. This method cannot be applied at the Dead Sea because the concentration of lithium is very low. Direct lithium extraction technologies that do not use natural evaporation make this possible. Direct lithium extraction technologies available on the market have low efficiency and cannot cope with such low concentrations. A unique method developed by Xtralit, based on the use of ion exchange in a sorbent powder, makes it possible to solve the problem of economically justified lithium extraction. The technology consists in the continuous passage of Dead Sea brine through columns filled with our sorbent. Our method does not harm the environment and the Dead Sea because after the lithium is extracted, all the water is returned to the sea without changing its chemical composition, only without lithium. The developed process can be easily combined with the existing processes of extraction of other elements from the Dead Sea brine. To demonstrate and optimize the process, we designed a pilot plant based on a continuous process in a stirring reactor. The pilot consists of a continuous stirring reactor, reagent storage and supply tanks, pumps for continuous brine supply, and storage tanks for permeable and processed brine. In the experiment that will be demonstrated, we will show the complete process of obtaining lithium carbonate from the water of the Dead Sea. The unit uses a sorbent that selectively absorbs lithium from the flowing brine. Water from the Dead Sea enters the reactor, where it interacts with the sorbent. After passing through the reactor, the treated water is returned back to the sea. After 10 hours, the sorbent is saturated with lithium and is no longer able to absorb. The flow is transferred to the second column, and in the first column, the extraction of the concentrate begins. We start by rinsing the column with water. This water can then be used again in the process. Now, stream diluted nitric acid. As a result, we get a brine with a lithium concentration 100 times higher than in the original brine. Moreover, the concentrations of other elements in this brine are much lower than lithium. Let's move on to the process of extracting lithium carbonate from the concentrate. We start with cold precipitation of magnesium and calcium using sodium carbonate. Let's move on to evaporation. We complete the process with hot lithium carbonate precipitation. As a result of our process, lithium carbonate is obtained, which is used in the production of batteries. Our process is economically justified and allows us to obtain a product with a cost of less than $4,000 per ton. The Dead Sea is potentially the source of one of the most valuable products, lithium. We are working on the implementation of a lithium mining project that has a huge economic potential. The future is already here. We are building this future.